Hello and welcome. In today's video we are looking at covalent structures, and in fact we're looking at giant covalent structures. Sometimes they're called macromolecules, which just means large molecules. Now the first example of a giant covalent structure is diamond, and diamond is actually a form of carbon. So if you were to look at the structure of diamond, if you were able to look at the atoms, you would only ever see carbon atoms in its structure. Now the key thing about the carbon atoms in diamond is that they are linked to 4 of their neighbours with covalent bonds. So all these dotted lines in this diagram represent covalent bonds, and as we know, covalent bonds are strong. So then you can imagine that if each of these carbon atoms is joined to its neighbour by a strong covalent bond, it's going to be very hard to separate them and pull them apart. And because of that very reason, diamond has a very high melting point. I'm going to be lazy and not write it out. And it also has a very high boiling point. It's because these atoms are so strongly linked by covalent bonds to their neighbours. Now the other thing about diamond is actually that it's a very hard substance, and again it's linked to this idea of these carbon atoms. If I was just to pull out a set of 4 of these and look at it down here, again you can see each carbon atom is linked to 4 neighbours, 1, 2, 3, 4, with these covalent bonds. In actual fact, the way they're arranged is quite a sturdy and rigid and strong structure, and all of the atoms in carbon are arranged in this way. So if you were to take out any bunch of them, you would see again they're arranged in that same manner. So what you should be able to do is explain that carbon is a very hard substance because it is linked covalently to 4 of its neighbours. Have I done that right? Yeah, I think so. The other thing it's probably worth mentioning here, actually, this diagram is not a very good diagram. It's quite hard to draw it in a 3D way for this structure, so if you're not quite sure, if it is a bit confusing, it might be worth just doing a quick search for a diagram of the atoms in diamond, or maybe even a 3D animation that might help you understand it a bit better. But the key idea is that we've got strong covalent bonds holding the atoms together, which gives it a high melting point and boiling point. Lots and lots of energy is required to pull these atoms apart, and also it's very hard, again linked to the fact that each carbon atom is linked to 4 of its neighbours in that way by covalent bonds. The next substance we're looking at is called silicon dioxide, sometimes called silica. And silica is made of silicon and oxygen atoms, and again they are covalently linked, but also they are linked in a similar way to diamond, and that makes it quite a hard substance as well. But again, same way with diamond, it has a high melting point and boiling point. If you're asked to explain why, again it's down to those very strong covalent bonds between the atoms. The next substance I want to look at is called graphite, and again graphite is a form of carbon, so you'll only ever see carbon atoms in its structure. And this arrangement I've drawn here is not supposed to be 3D as such, but if you're looking from above down at a sample of carbon and you were able to see the atoms, you would see them arranged a little something like this in these hexagonal shapes. The carbon atoms in this case, however, are only linked to 3 of their neighbours. So each carbon atom, 1, 2, 3, is linked to 3 of its neighbours. Again, they are covalent bonds, and which link the atoms together. But the specific and special thing to mention about carbon is that the atoms are arranged in this way, but they are also arranged in layers. So if I was to pull off this top layer, you would see a layer below in a very similar form, and again a layer below that as well. And these layers are not linked to each other very strongly at all. These layers can slide over each other very easily, and that makes graphite a very soft and slippery substance. So you should be able to explain the fact that graphite is soft and slippery because it's made of layers, and those layers can slip and slide over each other very easily. there are no covalent bonds between the layers, only between the atoms in the layers. Okay, so that's a little overview of graphite. The next thing I'm going to go over is actually part of the higher tier. So if you're not doing the higher tier, you don't necessarily need to watch, but of course you are more than welcome to watch along. Now, what I've tried to do here, again, it's about graphite, but I've tried to make it a little bit 3D by looking from a side-on sort of view of it. Not done terribly well, but I do need that view just to explain slightly better what we're going to talk about next. Two key features of graphite are that it conducts heat and it also conducts electricity. Heat and electricity, and you should be able to explain why it does that. And the reason for that is going back to this idea of the carbons being linked to other carbons. In this case, each carbon is linked to only 3 other carbon atoms, and what that means is that we have a free electron. Each carbon atom has a free electron, and in fact we call it a delocalized electron. You should know and understand that phrase there, delocalized electron. And this is just the same as in metals. Metals have delocalized electrons as well, and that gives it the ability for the electron to move around, and therefore it can conduct electricity. Not only can it conduct electricity, but these electrons can contribute to the graphite being able to conduct heat, because when heat is applied to some graphite, these electrons can move around more vigorously because of that heat energy given to it, and they can then bang into neighbors and pass on that heat energy, as explained in a previous video on conduction. Okay, so graphite can conduct heat and electricity because of these free electrons, or these delocalized electrons, that each carbon atom has. The other thing that you need to know about this is the reason why these layers can slide over each other so easily. So while the atoms in the layers can't actually move around too much, the whole layers can slide very easily, and the reason for that is that we have weak intermolecular forces of attraction between the layers. We've got strong covalent bonds between the atoms in the layers, but between the layers there are weak intermolecular forces, and that's the reason why the layers can slide over each other so easily. Okay, so for the higher tier, a couple of bits of information. Graphite can conduct heat and electricity because of these free electrons, or these delocalized electrons which can move around, and the reason why the layers can slide over each other so easily is because they are or they have weak intermolecular forces between the layers. Thank you for watching. Hope that was useful. Don't forget, there's a list of all the videos that have been made at mygcsescience.com. Other than that, that's me done for today. Thanks for watching, and see you again soon.